Hey, this is Step Ament. Welcome to my Exorcism.io series. Today I'll be working through the Armstrong numbers exercise from the Ruby track. And according to this description, an Armstrong number is a number that is the sum of its own digits, each raised to the power of the number of digits. So that's pretty tangly. So let's unpack that a little bit here with some examples. So 9 is an Armstrong number because 9 is equal to, and so remember what you do is you take each digit that makes up the number, so 9 is the only digit, raised to the power, or raised to the number, the power of the number of digits. There's one digit, so 9 raised to the first power is 9. And so yes, 9 is equal to 9. 10 is not an Armstrong number because when you run it through the algorithm, you get 1, and 10 is not equal to 1. 153 is an Armstrong number, though, because if you take each of the digits, there are 3 digits, right? So 1 to the third power plus 5 to the third power plus 3 to the third power is 1, plus 125 plus 27, which is equal to 153. So this is an Armstrong number. And so our task is to write some code to determine whether a number is an Armstrong number. So let's go ahead and grab the download link here, download code here. All right. Cool. So let's start. I'm going to start a new TMX session and open our test. And I'm going to go ahead and execute our first test. It's going to fail because we haven't created our an Armstrong numbers Ruby file that this require relative is asking for here. So I'm going to open a testing pane. Okay, cool. So let's go ahead and create that file. And I'll go ahead and switch the panes here so that my class under test is on the left. Now we actually have to create the class. This is going to fail because I don't have an include a class level method yet. Oh, wait a second here. Wrong argument type, integer. So, interesting. So does object, I gotta see what's going on here. I think object must have, it has include, but does it have include a? Yes, there it is. So I actually forgot about this. In Ruby, object has an include method, but we need to override that method. So this is going to fail. Again, it fails because include is expecting a module and not an integer. So let's go ahead and create our own class level method here called include that does take a number. This is the number under test. Maybe we can call it subject. I'll just call it number for now. And now it's going to fail because we return nil and it's expecting true. Expecting it to be truthy, right? So what we can do is simply return true. And true is truthy. So that's going to be happy. But that's, well, this is going to pass too. So we're going to have to go down to our first failure, which is this refute right here, because 10 is not an Armstrong number. Okay, so we actually have to do the work now. And so I'm going to go ahead and I think brute force this. Let's see. Let's look up the Ruby integer class. 2.5, that's close enough. And what I want to do, what I'm thinking now is I can't remember if there is a way to get the digits. Aha, here we go. Integer does have a digits. It will give me an array of the digits. That's exactly what I want to do. So let's go back here. I want to get the digits. So let's say number, digits. And I want to square each of them, or not square them, sorry. I want to do it by, I want to raise them to the power equal to the number of digits. So the way I'm going to do that is I want a new array. I'm going to map it. We call it digit. And what I'm going to do is I need to raise each digit to, I'm just going to brute force this number digits dot count. And then I want to, can I sum an array like that? I don't know if sum is a thing there. It is. Okay, cool. So everybody's working now. This is my brute force version, and I think this will just work. Let's see. Test 3-digit number that is an Armstrong number. This will just work. Test a 3-digit number that is not an Armstrong number. Yeah, and we've got the algorithm there. This is going to work all the way through. Yeah, I'll just keep going. I think this will all work. Okay, cool. So our tests are passing. And we've got kind of a gross solution here, I think. There's a little duplication. This number dot digits and number dot digits count. And so what I think I'm going to do here is I'm just going to start pulling things out. Okay, I could start pulling things out into other methods, but what I want to do is, first thing is I want to get this into an object. I'm going to call it, it's going to be Armstrong number. I want to new it up with the number and call include to find out if this is an Armstrong number. No, I'm going to call it valid to see if this is an Armstrong number. So the convention when you have this class level convenience method is usually the underlying method is named the same thing, but it doesn't, we're asking the Armstrong numbers class or module here if Armstrong numbers includes the number that we're giving it here. And so, I don't even know if this makes sense this way. I'm going to call it Armstrong number validator. That's the class I'm going to use to determine it. I mean, this is going to fail because that thing doesn't exist. So I'm going to go ahead and define it right down here. And it's going to take an adder reader for the number. And we need to take that on initialize. And then set the instance variable. And then we need to create a valid method, valid A. And I'm just going to paste in the code that we had up here. Oh. Let's clean this up. See if this works. No, Armstrong number validator doesn't work. Hello. Yeah, all right. Cool. All right, so now to clean this up a little bit more. If I were to work from the top down, I think what I would really want valid, what does it mean for this to be a valid Armstrong number? Well, it means that the raised digits sum, raised digits dot sum, is equal to the number. That's what it means. The raised digits dot sum is equal to the number. So what are the raised digits? Well, these are the raised digits, right? No, undefined method for false class. Oh, ha ha ha. Okay, not that part. Yes. Okay, so let's keep going with this because there's a couple of things I don't like about this, I think. Yeah, one is that we've got this duplication, this number dot digits. I really just want to ask digits. And so in order to get that, I know that that's number dot digits. My raised digits method has no business knowing that the digits come from number. This method, all that it's for is to take digits and to map them, to raise them to this count, right? So the next thing next question I have here is I see this digits.count, and I wonder if that piece of knowledge really belongs here. I know there's a power, there's an exponent. I'm just going to call this that, exponent. And I'm just going to hide that piece of knowledge here. Digits.count. And so now, let's see. Let me read this. Valid means that the raised digits sum is equal to the number. I think that's clear, and that explanation goes back to the algorithm, right, for determining whether a number is an Armstrong number. So what are raised digits? Well, you take the digits and you map over them, you raise each one to the exponent. Yeah, that's pretty clear. And it makes this method do one thing, right? This method does one thing. What does it do? It compares the sum of the raised digits to the number. This method does one thing. It takes the digits and it raises them. And it no longer knows what the exponent is or where it comes from, because this method doesn't need to know that. Exponent is here to just get to determine what the exponent is. It's the count of the digits. And then digits by itself, it just gets the digits from the number. All right, cool. I think this is it. I think this is what we want. So let me go ahead and submit this. That's my solution. All right, I'm going to continue on with the next exercise.